that's it. We are going to start this session. So first of all, Guillaume Cordoba is going to talk to you about the Nix shell. It is the agenda of today. Nix shell, and then Nastasia is going to talk about the RAS. From me, myself, I would like to pass through the gears to Guillaume Cordoba, please.
Sure. Could someone make me co-host? I can't share. Thanks. Okay, so I'm in charge of being brief. That's my first assignment. So I'll try to be brief, but my job is quite easy. It's really to just give you an overview of the Nix shell, why we have it, and how to work with it. Right. So to make a parallel, Nix shell is what we use in Holochain LAN instead of Docker, but for development. Right. So with Docker, what you get is a reproducible environment in which everything is virtual, but your Docker file, your Docker compose and my Docker compose are the same. So our environment should be the same. Right. But with Docker, it's a bit difficult to develop and so on. It's mostly used for production and for QA and things like that. Nix shell is used for development mostly. Right. So the answer, Nix shell is trying to answer the question, how do we get reproducible environment so that you and me have exactly the same environment when developing, right? And this Nix shell is a tool inside the family of Nix OS, but it's what we are going to do is not like installing a full operating system in your computer. It's just installing the Nix shell engine, and that's the engine that is able to do the reproducible builds. Okay, so right now I'm going to start from scratch. If you can see my screen, I don't have Nix shell installed.
Yeah, we can.
Okay, so I don't have Nix shell installed, and I'm going to walk you through how we can install it until we have a working Holochain environment, right? And for that, I think the easiest is I'll share this link later. This is the Holochain gym. It's one of the tutorials we have in the Holochain community. It has some requirements set up and so on. And then if you want to get started with the basics. For now, forget about all that. I'm going to just copy and run through the setup instructions, right? Important note, Nix is not working on Windows natively. So if you work on Windows, you will have to set up some Windows subsystem for Linux or a VM. Okay, so I'm just going to install Nix and add a cache for Holochain, the Holochain builds. Just going to copy and paste that, and it runs like it downloads everything, it runs through it. In the meantime, what I will do is clone this repository. And this is akin to cloning a repository in like a Holochain project or something like that, a Holochain ready application, right? So I'm going to go here and just git clone. Okay, and the most important thing here is that, oops, go the developer exercises. If you see here, there is a default.nix file, right? This default.nix file, you're going to see at the top level of hopefully every repository that works with Holochain. What this does is explicitly declare all the dependencies that your repository needs. Okay, so in this case, we have a project, default.nix in this project, and here we are declaring that we need the dependencies from Holonix, which is Holochain, and revision of Holochain release 108, which was released yesterday, I think. But whatever. This should be set by the creator of the repository or the authors of the repository. And when you download it, and if you see the default.nix, you already have to be thinking to enter the Nix shell there. So let's see. Oh, we let it run without waiting for the sudo prompt to run. Okay, so it shouldn't take that much time. Cool, so we have this. And I have to copy again this, like this. And this is really just to point to the cache that Holochain has prepared for us so that we don't have to be compiling every time Holochain, right? So now I have the, oops, sorry, I closed it. We have the cache configured, and now I go to the repository that we just cloned with the default.nix. And every time you see a default.nix within a repository, what you should do is do nix shell in the folder that contains the default nix. That's going to look for the default nix, going to just enter. That's going to look for the default nix, read the dependencies, and create a virtual environment for you with all the dependencies in the correct version, etc., so that you can start developing right away. So these are all cache. Previously, this would take ages, like 30 to 80 minutes in some cases. But right now, we are just downloading the appropriate things from the cache. And it should take like maybe a minute, if that. Then once you have done this, you will have installed both a Holochain command, that's really important, also HC command, which lets you pack applications, init new projects, etc. And importantly, imagine you're developing in different applications, right? The one of the main advantages of using Nix is that every project will bring its own default.nix to the table, so you don't have to keep track of which Holochain version every project needs, right? You just Nix shell into the default Nix in each of the projects, and they will give you the correct version for every case, right? So this is one of the main advantages that we have in Nix. Me, for example, I'm developing in 10, 15 projects, repositories, and it would be a nightmare to keep track of, okay, this project needed Holochain 102 and this other needed 103, and to keep compiling every time. So with default.nix files, I can just forget about all that, and the default.nix already gives me everything that I need. So let's just wait for this to finish.
Meanwhile, it is finishing. I Angers Dev, it is a little bit hard. There is no name. You had a question. Would you like to unmute and ask?
Yes. So, basically, the .nix file, is that some kind of DSL there, or what language is that?
Nix has developed their own language to be able to deal with dependencies.
Cool, thank you.
Yeah, like it's a whole wall. We don't have to get into it right now. What you need to know is this default Nix installed your Holochain.
Great.
That's it. And you can configure it to change the version here, but we are not going to do that hopefully in the DevCamp, so you can just forget about it. Okay, so we are now inside Nix shell. If you can see, it turned green, and okay, so now I have the magic Holochain command here installed. Holochain.in, okay, and now it's running. It's not finding layer key store, but whatever. And yeah, what else? I also have HC, right? And if I do exit, I exit the Nix shell, and here I don't know if I have Holochain installed. I do have it on my local environment. I don't know what version it is though. Right, so see, on my local environment, this was from another day. I have a different version. You can just forget about it. I can actually just remove it. I think it's this way. Cargo install. Okay, so now I shouldn't have Holochain installed. Cool. But if I go inside the Nix shell again, now the virtual environment is mounted, and I have Holochain again. right? Did I miss something, Nastasia, Hedayat? That wasn't the clearest explanation that I made, but I hope it's useful.
Yes, amazing, amazing. So, couple of minutes for any question. I hope you got the point. The environment is going to be really nice, handy, and easy to just start implementing. And also, your code can be totally isolated and independent from versioning. That's it, the beauty of the Nix. We are going to wrap it up, the Nix shell topic right now. That being said, Nastasia, here you are, please.
All right, so why would you want to use Rust and what are the reasons for this language? First of all, is that it allows you a very low level control over everything that's happening, which allows for greater customization and more flexibility in implementing anything that you want to do. Second is the memory safety guarantees, which are kind of baked into the design of the language. So there are more safety guarantees in Rust than there are in other similar languages. So for example, it would be much easier for you to shoot yourself in the foot in Rust than it is in Java or C++. And then Rust is also very high performant, and it allows the static code analysis, which is exactly how it offers you the memory safety guarantees. And I will get back to the static code analysis shortly because it's a very important feature of the language. Rust is also WebAssembly compilable, which makes it an ideal use case for the Holochain applications. And when you are deploying any Rust application, you would be dealing with a fat binary, which means that every dependency that you have for your runtime to be executed can be built into the same binary. So you do not have to worry about any dynamic libraries being available on the target machine. You just provide everything you need already built in, which is very nice and especially useful when you're managing multiple execution environments like microservices and similar stuff.
I have a brief question, Nastasia.
Yep.
You said it is easier to shoot yourself in the foot in Rust. What do you mean by that?
Oh, sorry, I confused my negations in English. I meant that it's,
okay,
it's
never
harder
mind.
to shoot. Yeah. So thank you for the correction. Yeah.
No worries.
Okay, so to make sure that I'm not coming up as a Rust fanboy, I also wanted to include reasons for why not to use Rust. And actually the same reasons that make it a good language for some use cases, they are making it a bad language for the others. So low-level control is nice if you want to customize something, but if you are trying to make something fast that would be just working, like a proof of concept, it may be a pain to deal with. For example, Rust doesn't hide any specifics of how strings are implemented from the developer, so you actually have to know the UTF-8 and the differences in encodings and how many bytes an actual character would take and all of that. And that could be overwhelming and just out of scope. Second is the strict compiler, which on itself is a good thing, unless you're trying to make something work fast. In JavaScript or Python, you could just write stuff and go on with it, but Rust wouldn't let you to build anything unless you satisfy a lot of criteria. And then there is a steep learning curve, which means that there wouldn't be that many Rust developers available, and that you could take more time to learn the language and to be proficient in it to write a production-grade code. And then the fat binaries is actually also a double-edged sword, because from one side, it allows you to package the entire execution environment and dependencies into, well, a fat binary. But from the other, if you're dealing with small devices like embedded or IoT or anything that's counting memory in megabytes, then fat binaries would be a problem because they would be overloading the system, and you may be better off using languages such as C, which are still relying on dynamically loaded libraries. So I would be focusing on the reasons to use Rust and how to use it. So let's continue. Static code analysis is a core design requirement in Rust, and there are actually interesting implications from this requirement. So first of all, there is no implicit type conversion for primitive types. And so if you see some, for example, an integer being passed into the function, you can be absolutely certain that if you do not see any type conversion being done explicitly, then this is the integer that wouldn't be, well, conversed. So that completely closes the possibility to make bugs with integer overflow, which have been plaguing all the languages. Second, necessity to analyze code statically provides certain weirdness in the syntax, specifically when we're talking about memory and ownership and lifetimes. These syntax things could be overwhelming, and they are, well, not the easiest ones to read. You get used to them and they absolutely make sense, but if you are new to Rust, that could be distracting. The good news is that we would not be covering lifetimes during the Holochain DevCamp like at all. We wouldn't be using them. So you don't have to worry at least about this part. And then one example of an interesting implication from my side about how static analysis is a requirement for the design is that you actually have two different keywords for finite and infinite cycles. So any cycle that has an end condition and absolutely has to finish at some point would be written via while. And I have completely confused my languages. I'm so sorry. This is a mistake in the slide. But the point is that every time you see the keyword loop, it means that the cycle is absolutely infinite. So static code analysis doesn't have to evaluate the condition of this loop to make sure that it's all working correctly. There are some other things that follow from the static code analysis, but I wouldn't be focusing on it too much. So I would first try to overview the building blocks of the language. So if you want to store some data in your application, these are the building blocks that you can use. So there are built-in types, which are pretty much standard. So there are tuples, hash maps, which can be called dictionaries in Python. That's basically the same thing. Vectors and many more built-in types, which are available in the standard library, and you can use them everywhere. And then there are structs and enums, and we would be using these two quite a lot during the DevCamp. And all of these things listed here can be or are already generic, which means that they could be used for different data types. And the resulting code for these things would be generated during the compilation time. So enums are a very fundamental thing in Rust because they actually implement two very important features. So let me cover quickly what makes a Rust enum different from, let's say, Java or C and C++ enum. So the same thing with the rest of the languages is that enum is defining a data type which has a limited range of possible values. So here, for example, we have an enum coffee, which has two different values, latte or Americano. What's different about Rust enum from the rest of the languages that I know of is that enum values can actually be wrapping other values. So in my example here, you can see that value for latte actually wraps the integer inside of it, and Americano is just a simple value on itself. And so if I'm creating an instance with this value, then I have to provide an integer. But if I'm using the Americano, I just provide the name of the enum and that's it. And if you're trying to print the enum value, instead of getting an underlying integer value, as you would get in C and C++, you would actually get a string name of this value, and I would show it later. Now, there are two most important enums in Rust, which we would be using everywhere. And first of them is an option. This is very cool enum because it implements the null value, which is kind of missing from the language, in the sense that in Rust, you cannot just go and define a value that would be null. A value can be either undefined and you wouldn't be able to use it in your code. The compiler would prevent you from doing so. Or it could be a value of the enum type, which implements two possible things, where it's either some value, which is why it's called sum, or there is no value. And so the null value in Rust is actually a special enum, which is like a placeholder for any null value. And the cool thing about it is that there wouldn't be no null pointer references during the runtime, because if you have something that could be without any value, you would still be using an actual value. We would show more examples of that. For now, I just want you to be comfortable with this concept. Second important enum in Rust is called result, and it's tied to the error handling topic in Rust. So when we are talking about errors, there are actually two ways to handle anything happening in the Rust. So first, you could return a data type result, which would contain the correct value t, meaning the result that's supposed to be a correct one, if your function has worked properly and returned the value that you would expect it to return. And then the second data type, E, which is inserted by the compiler during the compilation, is the data type for the error. And again, I would show my examples of it later during the DevCamp. For now, just know that anything handling errors in Rust is always using this enum result. There is a second way to just panic and crash the entire application, but we strictly discourage you from doing so in the Rust applications, because unlike the vanilla Rust, you would be crashing code which is being executed as a WebAssembly inside the Holochain conductor, and that would create a lot of problems. So if you want to properly handle your errors, you would be always using the Rust enum code result. Now, next building block for storing your data is called structs, and it's basically a combination of named fields, which could be of any type. And here, as an example, we can define a struct called order. So for example, a coffee shop, which is hosting this enum coffee I've written before. And there I can use the enum data type as a data type of one of the fields. And then I can use the primitive integer unsigned 16 bytes data type as a second field. And you can notice that when I'm creating the instance of the struct, I have to use name of its fields to specify how to map the values that I'm providing. And I'm using the latte that I've created previously, and I would show how it all executes together in the end of this presentation. So, okay, we now know how to store our data, but how do we define the behavior that's attached to this data? And to handle this, Rust offers both methods for static and dynamic polymorphism. For those with less programming experience, static polymorphism means that this is a behavior which allows you to implement different ways of behavior, but is applied and implemented during the compilation time. While dynamic polymorphism allows you to do all the same things, but decisions made are happening during the runtime. So when we're talking about the static polymorphism, one of the main things, the main thing being used for that is generics, which could be known to you from Java as templates, and yeah, C also keep it as templates. So these are code snippets which aren't actually the real code to be executed until the compilation happens. And so any type, let me scroll back. So that enum is an example of generic. You wouldn't be able to execute it on itself because you have to provide the T and E data type for this enum to be generated. That's one thing with generics. They require you to provide the data type to be used to actually create code from this template. And there are certain advantages to using generics. For example, they have zero runtime cost, which means that all of the code that has to be executed has already been generated by the compiler, has been optimized by the compiler. And when you are executing it during the runtime, you already know where are the methods, and you don't have to make any virtual table lookups in the runtime to find which method should be called for which instance of something. But there are disadvantages too, because if you're writing a lot of this template code, then you would be generating a lot of different code. So that could lead to some code bloat for your binary, which could be a problem in resource-restricted environments. I don't think it's a problem with modern backend development, but still something to be aware of. And second problem is that since generic is being applied during the compile time, it wouldn't be able to be so flexible to react to any changes in behavior happening in runtime. So there are certain cases which cannot be implemented by generics at all. And continuing the topic of static polymorphism, there is another tool called macros, which are applied before the compiler. So that would be something familiar for people from C++ background. And for now, I think you don't have to worry about macros too much because we wouldn't be writing them ourselves. We would only be using them as some tools, and you don't have to understand too much how they work. The main thing is that macros, pretty much as generics, don't have any runtime trade-offs, so you don't have to worry about performance when you're using them. And there are at least two types of macros that you would come across. First one is decorative, and it ends with an exclamation point. So every time you see it, you know it's a macro. And then procedural, which would be this hash symbol and then the square brackets with a macro name being inside of these brackets. Again, we would be using a lot of those, but never to the extent where you have to know the details of how it works. And now dynamic polymorphism. So if you want to implement something that's truly flexible and isn't generated during the compile time, you would be using traits, which could be familiar to you as a concept from other languages where they are called interfaces. So a trait is basically a set of methods that have to be implemented, that have a certain signature, meaning that they take certain input and they produce certain output. And then the actual implementation of the trait is up to the instance that's implementing it, pretty much like the interface. So the advantages is that this is very flexible and you can do almost anything, pretty much anything, because you are not restricted by the compile time checks, and you already have all the information available for making your decisions.
So, Nastasia caught it. It means internet issue. Yeah.
I'm sorry, I didn't know I was off.
Ah, you are here. Okay.
Can you see my screen?
Yes, I was thinking you
Yeah.
totally
How long was I away? I mean, I just seen my Zoom working.
I think maybe for 5, 6, 10 seconds.
Oh, okay, good. So this is the same slide I've been talking about.
Yes.
Okay, so traits. They offer flexible behavior, they reduce your code load, and they allow you to do everything during the runtime. But as a result, they would kind of reduce your runtime performance, and depending on your code design and amount of methods you have to do, you could be running into slower code issues. And also, since these things are happening during the runtime and Rust is all about memory safety during the compile time, there would be less safety guarantees for the code that's using traits, which isn't a problem on itself, but could be in some edge cases. And with the traits, they are offered by Rust in two flavors. Like you would see some standard traits which are built into the language, like copy and clone and debug and serialize and deserialize. These are that you would see across the entire DevCamp. In any module I think we're writing, we're using those traits. But then also you can define your custom traits for the things that you want to express with your business logic. And the mechanism to work with them is the same. It's just that if you want to see the behavior hooks which are thought of by the Rust designers, you can go and list and read about list of the standard traits which are already offered by Rust, because they control behavior of some aspects of the language. It's a huge topic. I just wanted to highlight that these 5 things are something that you would be coming across very often. So you shouldn't be surprised when you see them. Now, the memory model. So one of the difficult things for people learning Rust is the concept of ownership and how it applies to the memory model of the language. And here I will try to give a quick overview of that too. So first of all, Rust has no garbage collection. And when you're thinking about the memory flow in your application, you have to manually define it, but then compiler would do the rest. So you wouldn't see any explicit constructor or destructor calls. In fact, there are no constructors and destructors in Rust. It's done a bit differently. And then everything that you do for the memory flow in your application is just about using the Rust syntax to define where things are created, where they transfer the ownership and all of that. And for every variable, regardless of its type in Rust, you would see only 2 possible states. It could be owned by the current scope, meaning that this would be the scope which would be responsible for freeing the memory after this variable is stopped being used. Or it could be borrowed from another scope, meaning that the current scope, like function you're working with or a method or something else, only has the reference to this variable, and the actual memory for this variable is being managed by someone else, its owner. And when it comes to determining these rules, the memory flows, there are actually two rules which I think are important to keep in mind. So first of all, every variable would always have a single owner, but at the same time, it could have multiple things that it owns. So if you think about Rust memory model as a tree, you would just have to think about every node only having a single parent, but then it could have multiple children. So this flow is always preserved. And second, and I think this one is really cool, if you are sharing some variable, it could only be shared to everyone in read-only manner, meaning that there wouldn't be any conflicts of writes because everybody would only be reading from the variable, or it could be open for writes, but only for a single source. So it really helps when writing multi-threaded code because you know when your thread is getting something that they are using exclusively, or this is something that's being shared among multiple readers. And this rule is very important because it would be applied to anything you write in Rust, and there could be errors complaining about breaking this exact rule. And so with that being said, with the memory flow and all of these things, just keep in mind that compiler is actually your friend because it's doing a really good job explaining the problems in your code. And I will show you an example of that because the error hints and the warnings, they really help to understand how to better write your code. And they are much more comprehensible than for languages that have been written before Rust. I mean, I've been traumatized by reading C++ template errors, and Rust is much better, like so much better. And now Rust comes with its own tool called Cargo, which we wouldn't be using too much because Holochain wraps this together, but this is just something for you to know about. So Cargo is a tool which wraps all of the calls to compiler, which makes it easier for you to compile things without providing all of the options manually in the command line. It also takes care of the dependencies for your code. And it also manages the projects in the sense that you can create an entire project with modules and all of this stuff only using Cargo, basically a scaffolding tool for vanilla Rust projects. And when it comes to the module structure, we actually have a mix of those. Here I have tried to list everything. Yeah.
Nastasia, how much is it remain? If it is a lot, we can go for a break or...
It's the last slide.
That is great. Continue, please.
So here's the list of all the things that apply to the module structure from the list from the lowest level, where we have the Rust module, to the highest level, where we have a Holochain app called HAP for short. So Rust module is the smallest unit of code management. It's usually a Rust file, or it could be a directory with a bunch of files. And you can define things with different privacy level on the level of module. And then crate is something that you could be importing, something that you could be distributing actually. So for example, if you want to use HTTP handler, you would be using a crate called HTTP. And then a package is like an umbrella term for multiple crates. So sometimes you would see one-to-one mapping between a package and a crate. But in some other cases, you would see one-to-many mapping between package and a crate. For example, if you have a complex package, like some applied mathematics library or something else that's very big and complex, you would have a single package for this library, but inside of it, you would see multiple crates. And then anything written in Rust here could be a package, which would be in turn a part of the Holochain zone. And zone in Holochain is something like a microservice for your code. So you would be containing functionality inside a single zone if it makes sense for this piece of code to be used in different projects as a silo. And we would be talking about it more next week. Right now, I just wanted to give a context of how these terms relate to each other. So DNA could be including multiple zones inside of it, and then Holochain app could be including multiple DNAs. So that's the hierarchy that we have. And yeah, that's the last slide, and we can go for a break. And then after the break, I would be sharing some Rust code, very simple one, to illustrate some errors that we can get.
Thank you. Great job. Thank you. So let's see, when you are writing the Rust language, what you are doing actually. Imagine it is your network. I'm going to call it DHT. Yes. DHT. It is us, it is DHT, and the data is going to be here. The data on distributed hash table, yeah? Here, with the friends in the network. So different peers. I'm gonna call it the first layer as just imagine protocol. Protocol. So what does it mean? It means the things that going to be happen based on the propagating the data, distribution of the data, and we are not going to be engaged there. And also, if you would love to learn more about that, you can read in the basic concept and also in the really core knowledge of the technology you can reach there.
Khaled, I'm so sorry to interrupt you, but
Yeah.
I think it's a bit different question. It's
No,
more
I'm
about-
reaching.
Okay.
I'm reaching. And then we are going to have conductor. Each of you, each agent is going to have a conductor. So, and then conductor. So, and the conductor is going to talk to each other to fetch this data and provide for each agent. Then we are going to have another layer, which is conductor API. Conductor API. So, and it's bringing more knowledge to the pure data, like edited, blah, blah, blah. And then here, after this one, we are going to have another layer, which kind of a wrapper here, which is HDK. HDK. So it is at the top of conductor. So it means here, and I'm gonna call it HDK. Yeah. Okay. So what are you doing exactly when you are implementing any app? You are implementing your Rust here, app, which supposed to produce some WebAssembly, yeah? So it means you're talking to HDK. Let me change not with the same with this one app. New color app. So your app, which is actually Rust and produce WebAssembly, it's talking to HDK, HDK talking to the conductor and then to the protocol, and the data is going to be saved and produced. So it is your app. Right now, it is in Rust. Generally, this section is written in Rust, conductor. But HDK right now, it is in Rust, but it is not a must to have it in Rust. We can expand it to say we can have another one here. It's going to be the Java, for example. And you can implement HAP in another programming language. So if the HDK is going to be there generally, because it is just a one layer between the conductor API and to the whole ecosystem. So, and is there anything Guillaume would you like to add? And then
yeah, so one of the key things here is that what they have assumed as of now is that Holochain applications are compiled down to WASM. Right? If you don't know about WASM, it's a very interesting read. It's basically some step along the way in the web compilation and so on, that it's much more strict than JavaScript and things like that. And now other languages can compile down to it. So you can compile Rust to WebAssembly, you can compile C++ to WebAssembly, you can compile assembly script, which is TypeScript more or less, to WebAssembly and things like that. So by making the Holochain conductor WASM aware, you for free get all these languages that can compile down and create applications. Now, for you to have an easy time, you need this middle layer, the HDK Rust, which is exposing idiomatically and so on, the API that the conductor exposes, right? So for now, we only have the HDK Rust because it's efficient to start with only one. But in the future, as more and more HDKs for different languages pop up, you're going to be able to code in different languages.
That is great, complimentary, and also why Rust can be the best one that we started, the core team started from Rust, because Rust, when you're compiling your code in a Rust, so it is the upper level of the core. So if it's going to be memory safety management, it means your program is going to be compiled safely, and the lower level can be assured that you implemented a good software. It's going to be much more better and safe that this layer can just execute your application. And that's why I believe personally the Rust can be the best option, because your memory safety is going to be guaranteed compile time. That's it. I hope it could answer your question that why we can have it the other language later, but right now Rust seems to be one of the best options.
Yeah, thank you so much. It's over wide answer that I couldn't even imagine to get, but yes, I got it. Thank you.
Happy to hear that. If there is no other question, we can ask Nastasia to please continue.
Yeah, sure. Let me share my screen again. Okay, can you see my screen? There should be Visual Studio open there.
Yes, we can. There is a oh no, everything is great now.
Okay, cool. Okay, so these are the enum and struct that I've been already talking about in my presentation, and I just wanted to show you an example of how Rust compiler errors would look like. This is like a very simple example where I want to illustrate Rust compiler errors and then the memory flow. So first, what's happening here? Since I have already defined an enum, I'm creating an instance of this enum. And since I'm choosing the value of latte, I also have to provide some integer value because it's required by the definition. And so if I was to use Americano, then it could be just like that. And nothing changes actually from the standpoint of this object's creation. So now I have created this latte and I want to create my order. And for the order, you can see that I am providing this variable here as an input. And according to Rust ownership semantics, it means that on this line, the myLatte variable actually owns the memory that's created to store this value. But once I introduce this myOrder, then the memory created here becomes so it's no longer owned by the myLatte variable, it's now owned by the myOrder variable, because the enum that I have implemented doesn't derive the trait called clone, which is applied to all primitive data types. So now let me try to print these values because I want to see how compiler would react to me using variable which is no longer available. And you can see that I'm already getting some highlights from my Rust analyzer. And the problem is that I'm using the macro println, which expects everything that's passed to this macro to implement a trait called debug, which would implement the behavior of anything when it's being printed. So basically like a string method in Python objects. but neither of my enum or struct implement this trait, and that can be very easily fixed. But first, let me try to compile it here. So this is how errors look in the actual cargo output. And you can see that I'm trying to format these things like that, but I cannot do it because the trait is not applied. And you can see that it's been very helpful here, basically saying me what exactly I need to add to my code in order to make this code compile. So let me just copy this thing from here and apply it on top of both my enum and my struct. Now see how it goes. But the problem is, I only fixed one of the mistakes. First mistake was that I've been trying to print things which are unprintable. But now we can actually see the error about the memory flow. And Rust has detected that since memory allocated here has been moved in ownership to belong to this object, I can no longer use my latte here because it's no longer binded to memory that's been allocated for it. So if I want to continue doing so, I would need to duplicate this memory by making the clone here. But the problem is I'm trying to clone it, but my enum doesn't implement the clone trait, which would allow me to make a deep copy of the entire memory allocated for my latte and create another one that would be owned by my order. But lucky for me, that's also an easy fix because I would just add clone here and voila, just because I'm using macros, which are generating code for me during the compilation time. Now Rust is doing all the hard work of actually implementing the boilerplate code for these traits to be applied because my types are very simple. There is nothing too difficult about them. They are made up of other primitive types. So now that I have implemented the clone trait, you see that my code is not being highlighted as something with errors. And now it's all running. And you can see that this is the string that I have been trying to provide. And the enum value is being printed as it is written in the code instead of getting an integer value. And then the entire struct order is being printed like that. And a small hint, if you are using this notation, you can add a pound sign here, which would make for pretty formatting in Rust. So anything that implements the debug trait would be actually printed like that. It's not making much difference in this particular case, but it makes a huge difference if you're trying to debug something with more complex types and you want to be able to read your output. So to illustrate once again, what's the memory dynamic that's happening in my code, I made a small drawing. So first I'm creating my latte, which is of data type coffee. So this is the memory that's being allocated for my variable. It now exists. But now later, so this error is the time. Later as the time goes, I'm creating another variable, my order, for which I allocate different chunk of memory for the data type of order. But the problem is that order includes coffee in itself. So now this variable is owner of both this memory chunk and this memory chunk. And when I'm making the clone call on my latte, specifically here, I am actually duplicating memory, making it so that order now has its own instance of coffee. And this connection is actually here. So without clone, there would be only one coffee, but with clone, there are two separate memory chunks for the same data.
So that's it. Thank you, Guillaume. Thank you, Nastasia. Thank you, all of you. Especially also thank to Moritz that's supporting us about answer. Thank you, Moritz. It was really supportive and helpful. And really happy to see all of you here. And please continue conversation in the Discord. And if you need any help, please ask. And it is not just us, anybody going to support you based on their knowledge. Thank you. We love you. Have a nice day, evening, morning, or midnight. See you next time, and bye-bye. Thank you.